Yes, good day all. I'm back again to demonstrate how we can use the Python to obtain results for k-fold cross validation. And the earlier data used was assumed to be time series 21, 11, 24 up to 13. That is 15 observation, and using 5-fold cross validation. Okay, the first thing we have to do is to launch our Python. If you are launching from Anaconda, we'll click on Anaconda. If you click on lab here, then we launch it. Now, these are our Jupyter environment that we have launched. Then the first thing is to import the necessary, to include the necessary packages for the computation. The first package here is NumPy. NumPy is used for numerical computing. Then another package is ARIMA. We also import our mean absolute error, mean squared error from our sklearn.metrics. Then we also import warnings. These actually issue warning message of code without stopping program execution. Then talking about filter warnings, just to ignore warning. Then the first thing we are going to do after we have brought in the required packages is to load our data by using data equals to np.array. That brings our data to the Jupyter Python environment. Now once we have our data there, the next is to split into train and testing. So when we train the data, train_data simply means we say data :-3, that is first 12 observations for training or the next 12 observations for training, while for testing the first 3 observations, the last 3 observations for testing. This was actually taken in the reverse. We pick the first 2 observations for training, then the last 2 observations for testing. And that is what that stands for. We can see where the full column is at the back. That is the last. So we do that periodically. The iteration continues until the whole folds are exhausted. Now, the next thing is to fit our AMA PQ model on training data. AMA PQ simply means order PQ, autoregressive of order P and moving average of order Q. Then our D is equal to 0 because is of order 0. Now let's have our ARIMA model as DOS. Then when we say ARIMA model, the D is equal to 0. When D is equal to 0, it changes ARIMA to automatically AMA. So AMA_model is equal to ARIMA into train_data for our train data. Then we have our order to be 0, 2, 0, 1. Then we have our P equals to 2, D equals to 0, and Q equals to 1. Then AMA result is equal to AMA_model.fit. So that is for our specification. Then we have in-sample the training prediction. We now predict for the training. We have train_predict as that is the definition is equal to AMA is not a default. We can decide to use anything. We can target anything we like on the left hand side. But in my own case, I've just used train_pred equals to AMA_result based on what I have step ahead dot fitted values, and that will return my values. Then train_true equals to train_data. Talking about the first value is lost due to lag. We lose the first value at the lag1 that is required for stationarity. Now I want to forecast the future value. Now let's say we have our now have forecast equals to what AMA underscore result dot forecast. Then steps equals to 3, talking about 3 ahead, 3 values ahead. If assuming we have those 15 data points required, means day 1 to day 15. That is, we want to forecast for 16th, 17th, and 18th day. That's why we have step equals to 3. Then error calculations. We have our mean square error, R-square mean error for our training. Then we also have mean absolute error for our test and root mean square error, and it's defined as we have above. All right, now let's look at our attributes. To print, we first print our model evaluation, our AMA model evaluation, which includes all the model evaluation performance, model selection criteria, or call it model evaluation, which includes print for the MAE, print the train RMSE, print MAE, then print RME for the testing. So we have then the forecast. When we forecast the 3 values ahead, and that is what we have. That is for AMA model evaluation. Now we proceed to the ARIMA. The same thing follows, the same thing, the same steps earlier. In this case, our D is not equal to 0, as we can see, or the 1 1 0. So the D there, the middle one, is not 0 this time. So we have it as just a replica of what we have earlier for the AMA model. Then we have our ARIMA model has been produced, which is what we have here. And we can see our train MAE 6.17, train RMS 6.80, test MAE 17.63, test RMSE 18.03. We can see the forecast value, as mentioned in the earlier video, that it ranges between 25 and 26. Is not too bad. Yes. Now when we look at it, let's see what the AMA produced. 5.51, 6.51, you can see. So which are the values are lower. By implication, we say the AMA model better fit the model than the ARIMA model. And the point could be that the using ARIMA for this data is uncalled for. It is uncalled for. So, and which increases the overfitting. It makes the model, it makes the model to be overfitted compared to the AMA. And that is the procedure. That is how to execute this. So if we now have large data set, what we need to do is basically just bring in our data in the place of data equals to np.array. We just bring our data to this environment, we call it in, then we'll continue from there. Thank you for watching.